Very good morning, everyone. Today, we are going to see a problem on Thevenin's theorem. Take down this problem. Find the voltage drop and current through the 10 ohm resistor in the following circuit by using the Thevenin's theorem. So here, if you see this circuit, here one voltage source is there. Here one another resistance is there. Here also resistance is there. Here also one resistance. Here one voltage source is there. Here one resistance there. This is 10 ohms. So this point we have to consider as A and B. That is load resistance is 10 ohms. So what is the first step in the Thevenin's theorem is that to find out VTH. So to find out the VTH, what we need to do is we need to open circuit this load resistance. Okay. So just I am redrawing the circuit with the open circuiting this load resistance. Here we need to find out what is the VTH or VAB. So this point is A and this point is B. Okay, circuit I have redrawn. Okay, only I open circuit. So open circuit voltage we need to calculate or VTH or VAB or open circuit voltage we need to calculate. So for calculating the open circuit voltage, so here in this loop current is zero. Okay, because current flowing is zero because it is open circuited. But here one voltage source is there. So here majority will do the mistake here. So majority what they will do is they won't consider this loop and simply they will solve the problem. So here this voltage source, this battery source is there. Okay, we can tell us voltage source or battery source, whatever it might be. So here it is supplying 12 volts. Okay, so here this loop easy to find out what is the voltage across this point. Okay, voltage to 2 ohms we can easily find out by using the voltage division principle. So voltage division principle states that but say for example if you want to find out the voltage across that point, that particular resistance that is 2 ohms divided by total resistance 5 plus 2 into that voltage source supplying that particular loop. So into 20 volts. So here you can easily find out what is the voltage in the 2 ohm resistance. That is 5.714 volts. And here you need to find out what is the VAB and or VTH. This voltage, Thevenin voltage source, we need to find out. So Thevenin voltage source, how to find out the Thevenin voltage source in the sense. So here, if you see, as I said before, the current in this particular loop is zero, but voltage is there, supply. So simply what we can do is we can go for one Kirchhoff's voltage, Kirchhoff's, yeah, uh, sorry. So we have to make it a one mesh analysis. Mesh analysis means, say for example, if the current is zero, means this resistance has no value. Okay, there is no drop in this resistance. We should not consider this resistance. If it is short circuit, then the voltage drop in this particular resistance also we need to take into account. So how to calculate the mesh analysis in this particular loop is, so I'm taking the current direction like this. Why? Because the voltage source, you see the positive terminal is like this. So every time we'll consider like this only. But now I have considered the current direction like this. Okay, because the voltage source, battery source, here it is positive terminal. So this is the minus, say for example, this is the current direction, no? So from here we need to consider, say for example, this is the positive terminal, this is the negative terminal for VTH, like that I am considering. So if I'm considering this as positive and this as negative, then if you are in the current direction like this, so this is the minus to plus. The current is flowing from minus to plus. Minus to plus is rise. So rise is positive. So I'm taking this VTH. So again, if you consider this battery source, so current is flowing from like this. So this is minus, this is plus. So current is flowing from minus to plus. Minus to plus is again rise. So it is positive. So plus 12. Next, again, this has no value. As I said, this is open circuited, so no value. So like this, if I consider, so the current is flowing like this, flowing like positive to negative. So that is a resistance sources there. So it is a drop. Drop is negative. So minus 2 minus 2 voltage across this 2 ohms. So if you simplify this, VTH, if you take this side and this side means VTH is equal to V2 ohms minus 12. Okay. So V2 ohms is what already we calculated. That is 5.714 minus 12. So VTH is minus 6.286 volts. So that means this direction is reverse. What we consider is wrong. This we need to consider here minus here plus, like that we need to consider, because answer is saying like this. So VTH is equal to minus 6.286 volts. Next, to find the RTH. RTH is very simple. So for finding out the RTH, what we need to do is we need to short circuit the voltage source and open circuit the current source. Here no current source, only voltage source is there. We need to short circuit and we need to find out what is the RTH. So I have redrawn the circuit like this. So this 5 ohms and 2 ohms are in parallel, and that particular resistance is series with the 8 ohms. So 5 ohm and 2 ohm are in parallel and series with this 8 ohms. So 5 into 2 divided by 5 plus 2 plus 8. So if you simplify this, 9.482 ohms. That is the RTH. So next we need to draw the Thevenin sequence circuit. So Thevenin sequence circuit. So we need to. So usually we'll draw positive terminal here and negative terminal here. But Thevenin's voltage we got it as negative. So I have reversed the terminals. So minus plus. So 6.286 volts. Okay. So if you reverse the terminal, you need to take plus 6.286 volts. If you know, I will do always like a positive and negative here means you can put minus here. Nothing wrong with that. Okay, so as per the terminal, I reverse this terminal. Next is RTH. RTH we calculated. That is, we need to connect RTH in series. No, so 9.428. That is also connected in series. Next is that open circuited load resistance is there na, in the problem. So that we need to consider. This we open. No? That we need to consider in series also. So here, what I am doing is I am considering this 10 ohms in series. Okay, so previously I considered the current load current like this. Okay, like in this direction, but here the voltage source is reverse, no, like a minus plus. So load current is flowing like this. So we need to find out what is the load current. Load current, how to find out? Same Ohm's law only. So V by R. So V is what? 6.286 divided by total resistance 9.428 plus 10. So if you simplify this, we'll get the answer is 0.323 amperes. So current to 10 ohms is 0.323 amperes. So now we are going to calculate what is the voltage drop across this 10 ohm resistor, because as per the problem, because in the problem they ask what is the find the voltage drop and current to the 10 ohm resistor. Current to the 10 ohm we already found out. Current to 10 ohm or otherwise IL is we already found out. But now we need to find out the voltage drop across the 10 ohm resistor. So voltage drop across 10 ohm resistor is I 10 ohm into RL. RL means that the 10 ohms. So that also we need to consider. So I 10 ohms is already we calculated 0.323 into RL is 10 ohms. So if you multiply, we'll get as 3.235 volts. So this is the voltage drop across the 10 ohm resistor. This is the current flowing to the 10 ohm resistor. So like this, we need to solve this problem. So we need to be very, very careful in this particular area, because current is zero, but voltage source is there. If the voltage source is not there, no need to consider this particular loop itself. Simply you can neglect this loop. You can find out what is the voltage across this point and easily you can solve the problem. But here voltage source is there. So you need to be very, very careful uh, while solving this kind of problems. A very simple problem only, but the twist is here only. So we need to carefully do this circuit and we need to solve. Very simple problem. But here only the problem will arise. So like this problem will comes, you need to always you need to carefully do it and solve the problem. Okay. This is the answer for this particular problem.